Hi, welcome to the December 3rd meeting of the Kubernetes VMware User Group. In today's meeting, we've got, last I looked, a fairly light agenda. Robert, I think at the tail end of the November meeting, you brought up a discussion related to load balancers running on-prem for Kubernetes, and we didn't have time to cover it. So we're going to segue the tail end of last meeting into this one and talk a little bit about load balancers. Now, this is a repeat for longtime members of the group. We did have some coverage of load balancers back in the May 2020 meeting, but like all things Kubernetes, things change a lot. And even the way you might, from features of offerings to people discovering new best practices and deciding that there's a new way to do things that works better than the way people used to do it. So given that that May one was 6 months old, I think it's appropriate to go touch on the subject again. And with that said, let me get started. I prepped a deck starting late last night, so there might be some rough edges on this. I haven't practiced this or even gone back to proofread it for typos since I edited the last slide just about 10 minutes ago. So forgive me if there's some rough edges to this. So let me open this deck and share my screen. Just a moment, please. Okay, hopefully everybody can see a screen that says, what is a load balancer? Okay, great. So yeah, load balancing isn't new. These things became common in the 90s, way before Kubernetes existed. Maybe they came about before the 90s, but that's the first time I became aware of them. So they even predate VMs being used for services that were exposed on a network. So, why would you need one? Well, they're used to expose something to the outside world, and they can also distribute incoming requests that perhaps are at high volume across a number of nodes to allow improved capacity and maybe improved availability, such that if you have one instance of a service crash but have multiple, as far as users are concerned, for the most part, they're going to see minimal disruption. So here, let me move on to the next one then. So within a load balancing is generic. You could use it for kind of any network exposed service. But what does this mean in the context of Kubernetes? Well, it turns out that there's a couple possibilities here. One is to put the load balancer in front of the Kubernetes control plane itself. And this is actually a best practice for a large-scale deployment of Kubernetes in production. For availability purposes, the recommendation with Kubernetes is multiple nodes. The nodes should be an odd number so that you can do leader elections. And you would expose the API server behind a load balancer. The people consuming Kubernetes or using it go through the API servers. And it turns out that the architecture of Kubernetes itself has the worker nodes going through that same API server. You'll see in this diagram that came from the Kubernetes project documentation that load balancer is this central contact point. Things like the API, the controllers, scheduler, etcd, which is the reservoir of state storage, also is accessed through the API server. This particular one shows for redundancy 3 nodes, but there could be some other number. It shows etcd co-located on those nodes, but there is an option to stage independent etcd nodes that I've sometimes seen used. Now, let me point out a few things that maybe aren't immediately obvious here, particularly for people new to Kubernetes. Your objective for putting this load balancer here is to presumably allow for continued services if a single node fails or gets network partitioned. But this is only going to improve things if the load balancer itself has inherent high availability. You know, if the load balancer is a single point of failure, did it really add anything to go with this architecture unless that load balancer is highly resilient? Also, if you intend to use a software solution for your load balancer, and there are load balancers can be hardware appliances and or recent meaning, I guess these things have been out here for decades, but the first ones were hardware only. They can be software implemented, and it might be initially attractive to consider the possibility of putting that software load balancer in a container and hosting it in Kubernetes itself. But there are going to be some challenges with hosting this on the very same Kubernetes cluster it's going to protect. You know, you've got a chicken and egg scenario where what happens if you lose power to the whole cluster and it comes back up? The load balancer is how you talk to it, but if it's self-hosted, how is that going to work out for you? So if you're on-prem and you're running on VMware infrastructure, running a software load balancer in a VM protected by vSphere HA features might be a really good solution. You know, those people before the ages of Kubernetes deployed load balancers in VMs, and the VMs can allow for redundancy at the hypervisor layer so that that load balancer, even if it does look in this diagram like a single point of failure, might be extremely resilient using the vSphere HA features. There's another level of using load balancers with Kubernetes, and this is to load balance the services running on Kubernetes itself. So we're no longer talking about the control plane here. We're talking about either services you write yourself and deploy to Kubernetes, or many people find containerized software packages from third parties, either open source or not, that are capable of running in containers pulled from Docker image registries and hosted on Kubernetes. And if you discover that you would like to not only run these, but expose them out to the outside world, a load balancer can be a great, perhaps even necessary tool to do what would be termed north-south load balancing of your Kubernetes hosted service. Now, I like this diagram. It comes from the Cloudflare website, but it shows all the permutations you have with doing this. It turns out that you can actually do load balancing at multiple locations and layers. And for some use cases, maybe you want to even do them all. You know, this was prepared by Cloudflare, so obviously they have a business model of selling load balancer as a service hosted at their content delivery network sites around the world. And this would be kind of an initial point of contact for people or running applications trying to interact with a load balance service. This could, having the external hosted load balancer is an option, so it could be eliminated. But the next tier that's there would be a load balancer hosted by your cloud provider. And this diagram shows Google Cloud, as well as Amazon's AWS cloud. And those public clouds, in my experience, always have a load balancer provided by the cloud provider. And you pretty much have to go through that. That one is not an option. If you're running in that public cloud and using Kubernetes, the Kubernetes cloud what's called the cloud provider that plug into Kubernetes has built-in interaction with the cloud provider's load balancer. And this is the means by which you consume public IPs exposed on the internet. And once again, this one probably can't be eliminated if you're running in a public cloud. If you're on-prem, on the other hand, this one isn't externally managed. The load balancer might still exist, but it's on you to deploy it and on you to manage it. The Kubernetes architecture with regard to these load balancers, you'll find in the Kubernetes API a resource called a load balancer. It probably should be amplified to use the terminology external load balancer, because Kubernetes itself was designed as an abstraction, realizing that these cloud providers will have an existing load balancer that is subject to use and configuration in order to use it. So the Kubernetes resource called load balancer is a means to specify the configuration. But what happens is an external piece of code called a controller, I believe, monitors your declaration of intent that you make through the Kubernetes API and goes and properly configures this external load balancer so that it works in the way you've declared you want it to. You have the option of doing the same technique when you deploy Kubernetes on vSphere infrastructure using the vSphere cloud provider. But with the vSphere cloud provider, we intentionally did not build in a tight integration, because this would have required us to be a kingmaker and pick one particular load balancing solution to be deployed on-prem. And we just didn't think it appropriate to go there. So we realized that there are some on-prem deployments that might be using something like an F5 hardware load balancer, others that would use software-based load balancers, either hosted in VMs or bundled with a Kubernetes distribution. And by not putting the load balancer as a built-in opinionated choice within the cloud provider, we left it open for individual users to make their own solution as to what load balancer technology they want to use. But in any event, even though this diagram doesn't show the vSphere on-prem as one of the boxes, it's very similar to one of these public clouds, except that the load balancer choice is not an opinionated, hard-coded choice that's been made for you. It's up to you to go identify a load balancer solution if you need one. And then you would want to choose a load balancer that has some kind of Kubernetes tooling built in so that it can interact with the load balancer resource specifications in the Kubernetes API. Now, if you look at that top diagram on the Google Cloud in the diagram, behind the load balancer, it shows an Ingress controller. And that's another element here. You may not need a load balancer when you deploy Kubernetes on-prem, but a lot of this depends on the nature of your services. So there's another thing built into Kubernetes called an Ingress controller. And this does something similar to load balancing, but it presumes that you're up at layer 7, like HTTP. So it goes into the actual network protocol itself and uses characteristics of the inbound URL to potentially multitask one incoming IP to multiple web services, for example, by looking at characteristics of the URL. But for the most part, this is constrained to services that are HTTP, so that if you have things in alternate protocols that really aren't something that the Ingress controller can examine and use for dispatching. You might well need both. You might need a load balancer for some of your services. An Ingress controller might be viable for others. And you often might put the Ingress controller behind your load balancer and have both. Yet another complication here is that there are software solutions that came out here originally describing themselves as Ingress controllers, and they later added L4 balancing capability. So I sympathize with any of you who are users and newbies getting into this space, because when you Google search for this, you will find things that are self-described as Ingress controllers that maybe have an option to use them as a load balancer, and it can become pretty confusing. I'm not convinced I've fully learned this whole space. And I'm also going to give a caveat. I'm the presenter here, but I'm not self-declaring myself to be an expert on this subject. Really, this is a network thing, and I think you never stop learning on networking, and I'm kind of trying to cover a lot of things in addition to networking. So you're free to ask me questions, but I'm going to try to admit what I don't know here. There have been some people who've given presentations to this group in the past and who are on Slack, like Steve Sloka, who have deeper knowledge to me. So if you have tough questions on the details of these, feel free later to ask them in this user group Slack channel. And I think we've got people monitoring it who have deeper knowledge in this subject matter than I do. So load balancer versus Ingress, this is just a little history of it. I'm not going to read it to you. I think I kind of telegraphed this. Like I said, first time I'm giving this deck. So, there is this distinction of Ingress being up at L7, whereas load balancers would typically use addresses and ports that are found in the TCP packet header. L7 goes and delves into the actual traffic itself. And once again, there are some of these solutions. I know there are things that nominally describe themselves as Ingress controllers when you do the Google search that definitely have L4 capability, and there might well be L4 solutions that have L7 capability. So there isn't a black and white line here on some of these. Some of them have a gray line between their functionality. There is also this subject of east-west versus north-south load balancing. So north-south is about exposing services kind of to the world outside your Kubernetes cluster. But there is potentially load balancing going on within your Kubernetes cluster. If you use a microservices model, you're likely to have blocks of code that are talking to other blocks of code. And that's beyond the scope of this presentation today. Kubernetes itself does rudimentary load balancing. It's built into Kubernetes. You're allowed to put configuration information in your field definitions for services, things like type equals node port or type equals load balancer, some other options. I'm not going to go into this because this could be an hour-long 101 meeting by itself, but just understand that it's there, and handling the east-west traffic within your Kubernetes cluster is not what I'm talking about here with these load balancing options. That kind of thing you should just architect so that you're using the built-in features of Kubernetes, because that's what's going to make you cloud native, so that you could lift and shift an entire end-tier Kubernetes hosted application from on-prem to a public cloud, or from one public cloud to another. And that end-tier app shouldn't be able to tell where it's running and should just work as is. If you had an external load balancer there that's outside your Kubernetes cluster, if you're dealing with an entire app hosted within Kubernetes itself, that's probably an anti-pattern to go drag in the external load balancer, because that's going to break your portability. that external one you have on-prem is not likely to be the same one you have in a public cloud. So you're just looking for trouble. So keep your east-west using the standard plain vanilla Kubernetes functionality, and I think you're going to have a better road forward.
Can I add something, Steve, just there?
Sure, go ahead.
So in not the last slide, but the one before, you had like a ingress versus load balancer thing, and I just want to make it clear to everyone that it's not ingress versus load balancer. They have different purposes, but generally you use both together. So you use your load balancer, or something that provides service type load balancer to get traffic into the cluster, whether that's MetalLB or KubeVip or one of those kinds of solutions. And then you also use an ingress inside the cluster. So once it's got an IP, it routes the traffic to the ingress, and the ingress will do stuff like TLS termination, HTTP routing based on host headers, that kind of stuff. So generally you use both of these things together.
Okay, yeah, I fully agree. That's upon reflection, that's probably a bad title. It's just, I put versus just to explain what the differences are, because people often get them confused. And there are scenarios where you could live with just an ingress, particularly a full featured one. So I know that this is something where newbies often get really confused. In fact, even somebody working with Kubernetes for years gets confused on this.
Can I ask a question?
Okay, go ahead.
So you say that in the VMware use case, that there's not a very tight integration between controlling an external load balancer and Kubernetes itself. Does that mean that the configuration of the external load balancer is always pretty static?
Well, let me correct that. So I just want to point out, especially for first timers to this meeting, that this particular user group is hosted by the CNCF, and as part of the charter, we're required to not turn this into a commercial sales pitch and go into commercial offerings. So when I say they're loosely coupled and talked about the cloud provider, I'm talking about the open source cloud provider that is done for Kubernetes itself, like the piece that comes into play when you run any Kubernetes on top of vSphere. That could be Red Hat OpenShift. It could be that you download the source code to Kubernetes out of GitHub and build it yourself. It could be that you use Rancher, whatever. As long as it's Kubernetes, that cloud provider comes into play. And that cloud provider, unlike the ones for the Google or AWS cloud, did not build in support for configuring a load balancer because we wanted to leave the choice open. Now, there are commercial solutions where if you buy a commercial package, Kubernetes package from vendors like VMware is one of them, that might indeed bundle a load balancer solution so that it takes care of managing this and has an opinionated choice of the load balancer because it included a load balancer with that commercial product. But we're prescribed from talking about commercial products here. So they do exist, but like I say, I don't want to turn this into it's kind of a delicate area where if you start delving into the details of one commercial product, it's not fair to omit the others. And this just isn't the venue for that. So I don't know if that answered your question or not.
Okay, let me rephrase it. So in cases where there is no strong interaction with the external load balancer, then that means that the configuration of the external load balancer is going to be pretty static. So I'm just wondering what that configuration would usually look like. What is it effectively load balancing? And it's really only doing it on layer 4 then, if I understand correctly.
So are you talking about like an appliance, say like an F5 or something like that, Robert?
Yeah, let's say an F5.
Okay. Generally, like Steve said, to keep your app as like portable as possible, you probably want to use the minimum feature set that you can from any of those kinds of solutions. And if it does provide something, maybe just responding to a service type load balancer IP address allocation would probably be the best thing for it to do. Using an external like hardware load balancer like that with a Kubernetes app, you're not really going to see any benefit from it. You know, it's not going to load balance it across the nodes any better than any other solution that's just written in software that runs on top of Kubernetes would do. And it's going to add rigidity to the application. That means it's specific to that environment. So my opinion, at least, would be that if you are going to use some kind of hardware, external load balancer, whatever it is, that you try and use the absolute minimum features that you need, and then do any of the intelligent TLS termination, HTTP header routing stuff inside Kubernetes itself.
Yeah, and Steve, can I add one thing here also?
Yes, please.
Yeah, so things like F5 and things of that sort, a lot of them do offer also a controller for Kubernetes that you can deploy, which allows you then to use service type load balancer. So just because it doesn't come as part of the cloud provider, that part of the cloud provider can then be in that part that was taken out of the cloud provider from the public clouds can actually be installed separately as a controller in your cluster for different offerings, whether that be HA proxy F5 or doesn't matter what it is. A lot of them offer that. So you can get that same experience. You just need to generate that integration.
Yeah, exactly. In fact, I think it's fair to say that any you want to use if they're mainstream, unless they've decided they don't want to sell to people using Kubernetes, which strikes me as a pretty dumb decision. They probably are going to invest in allowing it to be controlled in an on-prem scenario.
Yeah, and I know you mentioned the cloud provider doesn't have the tight integration on purpose. It did just add in the latest release, I think, a optional integration with NSX if you're using that in the environment.
Yeah,
So
you're right about that, but
exist,
I didn't bring it up because that one's commercial, so I'm trying to stick with not going that direction.
Okay, cool.
And that being said, if there are any vendors of other external load balancing solutions there, given that NSX went in there, that cloud provider is open source and anybody can submit a PR on that project. So it does support NSX built in, but we've left open the option should other vendors, F5 or anybody else, want to commit resources to building something into the cloud provider as another option. I think the dev team on that project would be amenable to considering that. So these load balancers do have differences. So here in this slide, I'm calling some of them out, the degrees to which they do SSL termination to, that can be computationally expensive. When they load balance, one of the elements of this is to identify nodes that are not healthy so that you're not steering traffic to dead mailboxes. The technology used to determine that health check can vary. Even the way you configure what the health checks are has, in my experience, a lot of variability. Security features, bandwidth, well, I don't need to read you the whole list, but one thing I do want to point out for somebody going into production and kind of the fact that if you're using the load balancer for availability, it's already telling me that you're really concerned with availability and things like security. One of the big things to evaluate if you're still at the stage where you're choosing your solution, and this is personal opinion, but I think this is a lot like choosing a CNI for Kubernetes, the CNI being the network plugin, that there are many choices, but one of the biggest factors relates to the observability. If you want to maintain this in production, the world has devolved, unfortunately, this place where ransomware attacks are rampant and it's only a matter of time before I think you can be exposed to attempts to be attack attempts from black hat hackers. Having an ability built into your load balancer to do observability, particularly observability of traffic patterns related to Kubernetes objects, might be something that some solutions have and others don't. You know, it's great to have overall macro stats that, hey, my traffic level is X packets per hour, and suddenly it's quadrupled. So maybe somebody's doing a denial of service attack or whatever. But being able to map those potentially to individual Kubernetes clusters, to Kubernetes resources like pods or services would be a great feature. And if it could only tell you that this traffic is going to your Kubernetes API or going to Kubernetes in general, that's not as good as being able to track it all the way down to individual services, individual ingress controllers. And I propose to you that there might be some differences there when you go look at these things. And that could be far more important than one being, you know, maybe one can do 20% more traffic with a given number of CPU cores. But I think kind of your security features and your observability features might, that would be how I would choose my solution, not necessarily just, you know, the bits and bytes efficiency level. I would be interested in ideas from other users here in this meeting, though, because I don't want to be, I realize that's just my personal opinion. The next and final slide, I'm just calling out some load balancer options. These are just the ones, I think there's at least twice as many that didn't make my list here, but I didn't want to go to 2 slides. And I think these, by my personal observation, might be the more popular ones. So hardware, we already called out F5. There's a Barracuda solution. There are other hardware solutions. Cloud hosted, basically you're going to get the one that the cloud provider provides. You could conceivably add a software-based load balancer up there as well. But even that software-based load balancer might have to be hooked to the cloud provider's load balancer so that you stage them, you know, back to back. I'm not an expert on that subject, but I do know that typically people just use the built-in one from the cloud provider. In software-based load balancers, your solutions in no particular order, these don't mean to imply popularity. Seesaw is one that was originated by Google, and this is the one that on-prem Anthos Kubernetes uses, or it's the one they support anyway, and the one they call out in their docs. It isn't constrained, however. I don't see why it couldn't be used with Kubernetes implementations other than Anthos, though, and it is open source. HA proxy is, I think, a very popular one. I've frequently seen blog posts that describe how to deploy this with Kubernetes on-prem, and I've done it a few times myself. Nginx often is viewed as Ingress, and I'll caution you as a newbie with Nginx, there's a whole bunch of variants that are all slightly different that have Nginx in the title, and make sure you're looking at the right thing. I think Nginx got out there as a long time solution as a reverse proxy for web services, but it was open sourced. So in a way, I would almost describe these as forks that have Nginx somewhere in the title. And if you go out there reading about it, just be really careful that I know I got confused initially trying to learn about Nginx when I found 2 or 3 blog posts talking about things, and this is how this works. And I didn't realize that they were talking about 3 different variants of Nginx. And then when I tried to combine all of these instructions together, it just didn't even come close to working. So that is something to watch out for. traffic, and it's spelled, I assume they put TRAEF just so that you could Google search for it. But I've seen a number of presentation recordings on it where I believe it's pronounced traffic, even though it isn't spelled like that. And this is a load balancer that's commonly used with Rancher. So the Rancher docs would often lead you down a path of doing this. But it is open source and you could use it in other scenarios. MetalLB was one that was done by one person. I've heard some criticism that the originator of the MetalLB project announced that he was too busy and couldn't pursue this. And like some of these other, like many open source projects, they're often dominated by one individual or a very small team and subject to community health issues should that something happen to the originator. So I believe that came about in MetalLB to where there were some serious concerns about its potential future about a year ago. But then I've also heard recently that other people may have stepped in to pick up the ball and that might be a perfectly viable solution as a load balancer for on-prem. And I've used MetalLB myself. It's actually really convenient and easy to use. So I've done a number of talks where I needed a load balancer and discovered that and found it very easy to deploy and small enough in resources that I even managed to deploy it on a desktop hypervisor, literally running it on my laptop. So certainly for a learning experience, I personally have been successful with that. Whether that's suitable for a large scale production thing, that's for you to evaluate. Then finally, there's the commercial load balancing solutions. VMware's got a couple, Citrix has some. I'm sure there are others out there as well. If anybody on these calls wants to bring up one they're familiar with, go for it. One other thing I didn't cover, this is my last slide, but I want to point out that in the Kubernetes world, there are a couple things commonly used by people with Kubernetes, one of them being service mesh and another being serverless like Knative. And these also have the ability and maybe even the necessity to use a load balancer so that if you deploy service mesh, an Istio service mesh kind of expects to use a load balancer. That solution, I believe, is completely orthogonal to any that you might deploy for your Kubernetes control plane or for Kubernetes apps and services that aren't using service mesh, so that you could end up in a scenario where you have a second load balancer out there just to serve your service mesh. And I don't know why you would, but it might even be a completely different choice where you're using one variant of load balance. Well, I can see one reason why you do it. Maybe you're using a commercial distribution that bundled a particular software load balancer. So you're not going to want to switch that out. But then if you independently picked up service mesh on your own or from a second vendor, maybe it makes a different choice of load balancer and you ended up having two of them out there to maintain and feed. And then finally, like I said, you can use service mesh and kind of orthogonal to that. The original first generation Knative demanded using Istio, but the more recent release re-architected and no longer needs Istio and can just use a bare ingress or load balancer, so that you might potentially, if you're using Knative to get to serverless on Kubernetes, end up with another one floating out there like that. So I'm going to stop my share. I just finished the deck, so I didn't put a link in the agenda notes, but shortly after this meeting ends, I'll upload this deck to a Google Drive with a share on it and put the link in the notes for this meeting. So that's it. And I'd like this to be, this whole meeting on a recurring basis to be shared with users. So Does anybody else have thoughts or experience on using load balancers? I see even a few new people have popped into this meeting who I think might have actual experience using load balancing as a Kubernetes user. So I'd really encourage it and like if you could help out in this discussion to throw in your 2 cents worth.
I definitely think that KubeVip is also an awesome solution for the open source software load balancing, which can be used actually both for the API server load balancer as well as service type load balancer, and offers some really, really cool things like being able to set different CIDR blocks for the load balancer VIPs per namespace. So you could actually set up multi-tenancy, and things like that. So it's another really cool option to look at in that sphere.
Could you give us a little more color on the history of KubeVip and where it is and
yeah, KubeVip, who's behind it? I think it's Dan Finneran wrote it, who I believe used to work at VMware as well, formerly Heptio as well. But it's an open source project. It's actually what's used in CapV. So cluster API vSphere for the load balancer of the API server. It's based off of leader election, and it's a really lightweight, easy solution that offers really, it's adding support now for a lot of different options also, whether that be dynamic DNS support for load balancers and things like that. It's really moving forwards in UPnP support and different networking topologies. So it's one of the more advanced software load balancers. MetalLB is kind of limited to either just layer 2 ARPing or BGP configuration, which can get very complex in MetalLB for those that have dealt with the BGP configurations. And when it comes to KubeVip, it makes things much easier and integrates better with more complex networking topologies that you may have in your data center. So it's completely open source.
It's really good for home labs as well, I'll add, because Dan recently added a feature where it supports claiming addresses from DHCP for service type load balancer. So even if you just have a home lab, and I run my Raspberry Pis on MetalLB at the minute, but I'm moving them over to KubeVip, and the idea is with MetalLB, like Scott was saying, you have to give it a static layer 2 CIDR, and honestly for like home lab stuff it's easier to just use DHCP for some workload things that get spun up and down. So KubeVip has DHCP support, so it'll claim an address from DHCP and then ARP for that address the whole time, and in addition it's added UPnP support, so it can actually punch a hole through the router dynamically as well, so you don't have to set up any fancy forwarding or other load balancing solutions like an Nginx proxy or something on your inbound network. So it's good for small scale labs too.
That sounds great. It's one thing I failed to mention but should have on load balancing is some of them have sort of what I would call almost an IPAM feature or integration, in that you hand them over a block of IPs and they handle allocating and assigning IP addresses out of that. They may not go put things in DNS for you though, but if KubeVip goes off in that direction, particularly the DHCP, I can see that as being really attractive, particularly for home lab and people playing around trying to learn things.
Yeah, I think the one other thing that's really interesting to note also is that the cloud providers, the extreme scale ones, whether that be Google, AWS, Azure, are actually now going also through the process of removing the load balancer from the cloud provider itself and making that a separate controller, because, and that's happening through a lot of that is because of cluster API and things like that, trying to separate it out to make that also pluggable for whether that be F5 in a cloud solution or any other commercial offering that certain customers have wanted. So that's already happening. AWS have already done that. So what we have in vSphere now, this capability, it's not even a limitation really in my mind, it's a capability to choose what you want as the load balancer, is actually the way the cloud providers are moving into as well.
Yeah, that's interesting. I was just watching some of the reInvent sessions this week, and AWS has announced a version of EKS that can be hosted on-prem. So I can see that maybe another reason for them breaking that out is that if they intend to convince the world that their cloud-hosted distribution is viable for on-prem, that step of divorcing the attachment of the load balancer would seem to be necessary.
Yeah, there was some
Yeah.
good conversation in the channel as well while we were having this meeting, and while Steve was talking about basically this exact thing. And there was an interesting link that I'd never seen before, which was a comparison of Kubernetes Ingress controllers. I dropped it in the chat, and I threw it into the documentation as well, or the overview doc that we have for this meeting, and it gives you like a blow by blow, feature by feature, what each Ingress controller supports. And further to Steve's point, all of the different variations of Ingress are in there as well, so you can tell exactly which one does what.
Okay, anybody else have experience with or opinions or questions on load balancers? Okay, I'll take silence as no. And as always, if you think of something after, or you had something going on your Zoom call where you couldn't unmute and talk, go throw it in the Slack channel and we can cover it later. The next thing in the meeting, I haven't gone back to see if there were any late adds to the agenda. Just a minute, let me look. But I think maybe Miles, maybe you can say a little bit about what you've been up to with regard to GPU. I know that you were doing this, maybe aspiring to be able to talk about it today, but that we're going to roll it into the next meeting, but maybe you can give us a little teaser.
Yeah, so I've been building a stack, if you want, and a presentation for the vMugs as like a roadshow. So I'm doing that with a guy on my team called Niels Hauhoort and another guy called Johan van Amersfoort, who Robert works with. And we're basically showing what it takes to run an ML type workload on Kubernetes on top of the VMware stack. So we've actually written all the code for this. It's all up on GitHub. All of this stuff you can do today. It works just, with what we have today. We're using Bitfusion inside of our container to remotely mount GPUs over the network and dispatch jobs of ML image processing to them. So the story is there's like a flower market and it's trying to automatically count flowers. And what we do with Kubernetes is use horizontal pod autoscaling. We set a desired processing rate. So say I want to process 400 flowers per second. I set that in horizontal pod autoscaler and it'll scale out and keep allocating GPUs until it can actually meet that. So rather than having a workload defined as okay, we've got this ML workload, we're going to give it a GPU for a slice of time. We wanted to focus on the outcome. So we've got this workload, we would like to make it run at this rate, and then we just let the system figure out how much resource it needs to allocate to achieve that goal. It isn't quite working just yet. Like I said, it was deployed just at the start of this meeting. It's not up and running now, but we'll have a look at it next week, or next month.
Maybe I don't want to steal too much out of your next month, but maybe if you can tell people not aware of Bitfusion what it's about. I think, if I'm not correct, that it goes and takes a physical GPU, potentially even carves it up into sub-allocated, call them virtual GPUs, if you will, that
Correct.
can be consumed across nodes. So you're not necessarily tied to running your workload on the actual physical compute hardware where the GPU card is plugged in. Is that true?
Yeah, this is exactly right. And this is why I like Bitfusion versus any of the other solutions that are out there today, because there's NVIDIA vGPU and there's a whole bunch of different ways that you can skin this, particularly on Lucky Cat. But Bitfusion, to me, aligns really nicely with the Kubernetes way of doing things, because it doesn't tie the GPUs and those GPUs into the nodes in the cluster. So if you deploy your Kubernetes cluster, you don't have a hard allocation of, there's a GPU in each one of those. rather the way Bitfusion works is it has two different components. So there's a server side and there's a client side. And the server is a VM, which you actually do pass your GPUs into. You pass as many as you need. And then the client is something that you add to your Docker file. So it's just a Debian package that you add into your Docker file. Obviously, the Docker file is probably going to be written on Ubuntu because that's where most machine learning stuff goes. But you install this Bitfusion client, it automatically discovers all of the servers that it's connected to. You pass it a CA cert file, and then it can do auto discovery. So whenever it spins up, it'll ask automatically Bitfusion, hey, can I have a GPU? And then Bitfusion has this magic, because frankly, I don't know how it works, where the client connects to the server and it allows it to dispatch jobs of, whatever. So in this case, in this application that we're building is a image inferencing TensorFlow workflow. It passes those batches of images to the Bitfusion server. It does the computation on the GPUs and passes back the result. And that works really well for ML type stuff because you don't need a high bandwidth connection between the GPU and the client. All you want to do is pass the job over, get it processed, and get the result back. So that's what we're going to be looking at next time.
Okay, that
It
sounds
also-
really cool. I guess.
Go ahead, Scott.
Yeah, no, I think Bitfusion also adds a huge capability in this sense also because it makes the setup of your Kubernetes cluster much easier in terms of drivers and things like that within the OS. Anyone who's dealt with NVIDIA drivers in their worker nodes and things like that, it's not a fun task to deal with. So Bitfusion completely eliminates that.
Yeah, and it doesn't matter what your underlying node OS is either, which is critical because again, you don't install the NVIDIA driver on the node anymore because this Bitfusion shim, I guess you could call it, gets added to the container. It takes over those CUDA calls and the driver stuff and dispatches it to the Bitfusion server instead. So it actually keeps your Kubernetes clusters really quite tight. You don't have to make any underlying changes to the node configuration to support that.
Yeah, this sounds great because having lived through a lot of the warts that people discovered in storage, storage is this scenario that has historically always been somewhat problematic. Some of the reasons are, and some of them, unfortunately, we still somewhat potentially suffer today of mounting external volumes to things and having the compute migrate from where it was, yet still having to discover and reattach to the volume. Caused problems when you went to things where the storage was dispersed on the compute nodes. It initially sounded like a great idea, but some of those solutions forced you to go in lockstep. If you had to expand compute capacity and keep the nodes heterogeneous, that was problematic because maybe you had to spend money on storage you didn't need, or vice versa. To expand storage, you had to buy extra compute nodes that maybe you didn't need the compute capacity. And being able to break these GPUs completely independent of the compute nodes really should offer you a lot of flexibility. The other thing I have to observe is the GPU space seems like more rapidly moving than even maybe the compute, in terms of our x86 CPUs still moving along the Moore's law path. Maybe not so much, but GPUs from one generation to the next seem to be going up pretty dramatically. But realistically, you as a particular on-prem user don't want to buy a bunch of those, discover you want the new model a year from now, but still have to capitalize the expense of last year and don't want to throw them out. And suddenly you've got this non-uniform resource out there that you've got some Model X GPUs, some Model Z GPUs. You want to use them all. Maybe this Bitfusion gives you this great opportunity to abstract out the differences, just like virtualization did for allowing non-homogeneous hardware to kind of act the same. And Kubernetes allows you to make different clouds act the same. Having an abstraction on top of the GPU chip seems like a fundamentally great idea. So we've got 2 minutes to go. So time check, last call. Does anybody have any other subjects they want to bring up? Or better yet, since the time is limited, suggestions for things we can recruit presentations on or discuss in the January meeting? Okay, I'll take silence as nothing immediate.
I've got something.
Yeah.
Didn't wait quite long enough. So I posted something in the Slack channel about some issues that I'm seeing with basically after a NIC failure, which we've seen this happen during DRS events. The kubelet doesn't reconnect. So I think Scott replied. Scott, you replied to me earlier today. It's something that we have thousands of clusters, and it's something we see pretty regularly. But it's not something we've been able to purposely like reproduce yet. But one of the comments on that Kubernetes issue is for the workaround for VMware is to disable DRS, which kind of defends the point.
Yeah, I understand.
Yeah, so on that GitHub issue, they did mention that it's fixed now or will be fixed in 120 and then cherry picked back to 119, but not earlier than that. So it seems it's a core Kubernetes issue with the Go packages it's using that's going to be fixed now in 120 when that comes out.
Yeah, so and it looks like they merged and they backported it to 119. I don't know if they've cut a version with that yet, but right now we thought we have it's kind of a workaround that's based off of that thread.
What version are you using, Bryson? Or
we're using Kubernetes 117 and we have vSphere 6.7.
Okay.
So we're trying to investigate what's causing some of those issues, but we're not encountering this on other hypervisors or other clouds. So right now we're only really encountering this on VMware, and it seems to be relating back to when there's like a DRS event or basically a DRS event.
On the other
but not always. Like when we do DRS, like we try to make it happen, we haven't been able to like forcefully like recreate it. So sorry, what was that, Miles?
On the other hypervisors, is there live migration enabled as well, just so it's like an apples to apples comparison? Like, are they doing a stun, for example, doing a live migration and then unstunning the VM, or is that exclusive to the VMware platform?
I'll have to investigate exactly how they're doing it, but
so the only thing that I can think of is whenever a VM moves from one ESXi hypervisor to another in a live migration, the VM gets moved to the other side, and then the vSwitch reverse ARPs the address, or gratuitous ARPs that address backwards to update the switches to say this IP address now lives on this MAC address, which would probably align with what Scott is saying, is that there's probably some logic missing inside the Go code to account for that kind of MAC address change or something similar to that.
Yeah, it's basically when kubelet doesn't connect, its connection dies, but the underlying HTTP2 connection from the base Go code actually stays alive, not allowing kubelet to come back up. Okay. So you have to run like a cron job that basically checks for a certain log in journal CTL is the workaround and restart kubelet on the node. That's the workaround before 1.19 next cut release.
And we found, so we've implemented like that, similar to what other people put as a workaround. First it tries to restart the kubelet. If restarting the kubelet doesn't work, then it'll restart Docker and the kubelet. And I think and that has reduced the number of issues that we have coming out of this. But then with the funny thing is, I don't know when this got introduced because we didn't used to have this problem. But the area, even after adding those workarounds, what I've found is we'll still have encountered this issue. And what I'll go and I'll manually try to like restart Docker and Kubelet and see if that works. And I found that even doing that on some situations, we're left with a container D processes that are kind of like hung. So even if you stop container D, they're still running. And so I think we're going to have to add like even further workarounds to like go in and restart that and or stop it. And if they're still hung processes, kill those and then start everything back up. But I just wanted to make sure like others might not be seeing it as much as us because we've got so many different clusters running this, but it's definitely an issue that we've seen.
I don't know who we've got in what roles on this meeting right now, but it'd be great from my perspective if we could link up Bryson if he's got an ability to test any proposed solution, or maybe the 120 release is the solution, but I'd prefer to see it actually tested to prove that this was the root cause and it's been fixed.
Bryson, as like an interim, and I know this isn't a fix, but to maybe make sure it doesn't happen as often as it does if it is related to DRS, change the aggressiveness of the DRS algorithm down to the lowest that it is, so that it'll only move stuff in the event that it needs more resource on a given node, because there will be no performance benefit for that anyway. So just turn the DRS aggressiveness all the way down to try and limit the number of vMotion operations should at least, you know, stop this from occurring as much.
So we currently have affinity rules set up so that they only move if they really have to.
Okay. Okay.
So we have our masters separated onto different nodes and workers on different nodes. And then if that vhost is gone, then it'll try to start it up somewhere else.
Right.
But
okay.
if it comes back, it'll move it back. So
my guess is also
preferred.
It would be interesting to see also if this does happen 7 as well with the changes in DRS. And I mean, the stun time in vSphere 7, I don't know where you are on your migration to 7, but the changes in vMotion and DRS and the shorter stun time that happens should make it also less common, would be my guess, just based off of those changes. It would be interesting to see if it's reproducible in a 7 environment as well. Just because of those underlying vSphere fixes that happen to make it better.
That is if it's related to stun time. However, if it is related to a MAC change, which it may be, then it would make no difference because the fundamental fact is there would be a MAC change anyway. So if it is stun, then that would fix it. But if it is MAC address changes, any vMotion operation could cause that.
Right. But no, considering that if it was MAC address changes, I would think that you would see it more often in more environments, meaning my guess is that it's the DRS stun time in those specific cases, because if it's not reproducible on a regular case of here, I just reproduced it, it does deal with a MAC address change. Maybe there's some issue where at some point it didn't, but it seems the stun time is the logical place that it could be starting from, but who knows?
So by not reproducible, are you telling me that you can force a DRS migration and it doesn't always happen? Because there should always be a MAC address change when that happens, right?
Yes, I'm saying we haven't been able to, like, literally, like when we try to do it, it doesn't happen. One thing we found, most of these times it's happening during maintenance that they're doing on the nodes or on the hosts. And so they'll put one into maintenance mode and then and kind of go throughout the rest. And we actually found it more likely to happen in an environment that is running some different hardware. It's running VxRails. And so we can't necessarily purposely reproduce it. We've tried to do what they were doing in production that we were encountering it, trying to do it in our lab, and didn't encounter the issue. But when they're doing some of those upgrades, it's pretty often that it happens. But like I said, like sometimes when you're looking at it, trying to find it, you know they're going to do an upgrade on it. It doesn't happen. So it's not every single time. But
if it is more common with upgrades, I would say that does lend evidence or credence to the stun time thing, because the stun time scales based on the bandwidth allocated to vMotion. So the more concurrent vMotions you have going on, the longer your stun time would be, which would make sense then, because if you're evacuating a host, you're evacuating all the VMs, which means you would have the longest possible stun time.
okay.
Which is why a possible workaround, I mean, it's a manual one, but when they're moving things into maintenance mode, would be to migrate some of the VMs manually first, migrate them in sections, your VMs off of the host, and then put it into maintenance mode when there's less VMs on it, so that the stun time of those VMs is shorter. So if you had 50 VMs on the host, move them 10, 10, 10, 10, and then let the maintenance mode take the last 10 or 20 off of it automatically, but that should shorten the list of vMotions happening and shorten the stun time accordingly as well.
Bryson, on the different hardware, another thing to check would be, you mentioned VxRails. I believe they're all 10 gig NICs. If you see that on 10 gig NICs and not more dense NICs like 25, 40, 100 gig NICs, that would also make sense, because then there's not as much bandwidth for vMotion to use, which would again result in longer stun times on a vMotion operation. So if it's older hardware you see it on, look at the NIC size of the affected hardware versus the hardware that you don't generally see it on.
Okay.
Okay, maybe we can keep this going in the Slack channel then. And we're 10 minutes over already. So let's declare this meeting over and look forward to you next time. I did look, by the way, I was concerned that the meeting next month, we're always on first Thursday. I checked to make sure it didn't fall into the New Year's holiday, but it looks like we're safely into the second week of January, so that the meeting should be at the normally scheduled time. And hope to see all of you and invite your friends so we get even more people, and catch you in January. So bye, everybody.
Thanks, everyone.
All right. Thanks, Dave. Thanks, Miles.